Okay, so this is the most foundational chapter that you need to know for your entire physics syllabus. This will be on the chapter on forces. I'll be covering mainly the 3 laws that you need to know, as well as some key concepts to take note of. So first one over here, it says what exactly is a force. A force is simply a push or pull. You learned this in secondary 2. And a force can do 2 different things. So a force can either cause an object to change its speed or change the direction. So imagine I got a moving object that's going this way, and then I exert a force. This moving object will eventually, if there is sufficient force, turn and go in the opposite direction. There are a few different forces that you need to know. First one is your contact forces. Second category is your non-contact forces. So under contact forces, again, you have multiple different types of forces you need to take note of. The first one is simply friction. So imagine you're walking on the ground. The reason why you won't slip off the ground is because of friction. And what friction does is friction opposes motion. So let's say I got this object that is moving towards the right-hand side. My friction is exerted on the ground and it will be towards the left because it is going towards the right. So it's opposite to the direction of motion. Direction of motion means the direction of travel for this object. Second one is air resistance. So air resistance is something that we feel every time we walk, every time we start running. And air resistance is dependent on 2 different things. So first one is speed. Second one is surface area. So imagine you're running and then you start speeding up. What happens is you feel more wind blowing at you. And same thing, if let's say I got a skinny guy that is running versus a very big guy that is running, the big guy will feel a lot more wind that is blowing at him. So what that means is that when my speed increases, my air resistance will actually increase also. And then if my surface area increases, my air resistance will also increase. So let's say I got this guy that's moving towards the right. The air resistance again will oppose motion similar to your friction, and it will act towards the left. And for this air resistance, you don't have to draw it on the ground since it's in the air. You just need to make sure that your force is acting on the guy. Third type of force, this is tension. Tension is present whenever you have a string, whenever you're pulling something. So on this object here, you have tensional force as well because you have this string up here that's attached to the ceiling. There are a few things you need to note for tension. Tension must always be away from the targeted object. What does that mean? So let's say I got this object here, and then I want to find out which direction the tensional force is acting. Just know that the tension on this block will be acting away from the object. So the object is downstairs, you want it to act away, so therefore your tension on the string should be upwards. This is tension on the block. And then for the tension on the ceiling, it will be away from the ceiling also, so it will be downwards. This is tension on the ceiling. So to fill in the blanks, tension on the block will act upwards, and then tension on the ceiling will act downwards. Last force that we need to know is normal contact force or normal reaction force. This is normal reaction force normally by the ground on the block. So let's say I got this ground over here that is acting and resting on this ground. What will happen is you will have this force, which is called your normal contact force, exerted on the block. Why is there existence of this normal reaction force? So imagine, let's say I got this file here, and then I rest my hand on it. If there's no normal contact force, then what's going to happen is that my hand will literally sink into this file, which is not what you want to happen. That's why there's normal reaction force acting on every single surface. So let's say if I got my 2 hands here, if my 2 hands don't slide into one another, then what that means is that they're exerting normal reaction force on each other. So I would think of it as your anti-sinking force, or a force that prevents things from going into one another. Every single surface will have normal reaction force. If I have this thing here and then I'm pressing it on my hand, same thing, I will have normal reaction force that is exerted on this airport as well as my hand. In this scenario, we have normal reaction force, and the normal reaction force that we want to care about normally is the normal reaction force on the block. And in this case, it will be acting perpendicularly upwards from the ground on this block here. So take note, normal reaction force exists on every single surface. Whenever you have 2 surfaces in contact, there is normal reaction force. And secondly, normal reaction force is always perpendicular to the surface. Next part will be on non-contact forces. So main non-contact force that you need to know is simply weight. Weight must always come from the center of the object. So in order for me to find the center, it'll be somewhere here, I'll draw diagonal lines, and I can either write it as weight or I can write it as gravitational force. Both are the same, and your weight is always exerted by Earth. So Earth is the one that's exerting weight on us, not the ground, not ourselves. We have these two scenarios here, as well as one last scenario down there. That one will be for airplanes. We'll try and draw this one. So this question, they're asking for the different forces that's exerted on this block, and then you have a rough surface. There's a ground, there's a surface. Normal reaction force will therefore be present. This is your normal force. And then besides that, for every single object that is on Earth, there will be weight. And weight is always vertically downwards. And then there's one more force in this scenario because it is a rough floor. So rough floor, the block will slide downwards. So to prevent it from sliding downwards, there'll be friction that's acting upwards. Second scenario here, this one is a bit more tedious. So I have two rough surfaces and then I have a block that's resting on the wall as well as the ground. So naturally there'll be normal reaction force. This one will be perpendicular to the surfaces that's in contact. And then besides that, same thing, we have your weight. Weight will originate from the center of the object. And then there are rough surfaces, so that naturally means that there will probably be friction. So this block, when it goes down, this portion here will slide down. This portion here will slide towards the right. So friction opposes motion, and therefore your friction on this wall here will be upwards. And then your friction on this ground here will act towards the left to oppose the motion that is going to be towards the right.